Amid the chaos of deep space, astronomers stumbled upon something they can't quite explain, a near-perfect bubble, quietly floating in the Milky Way. It's not a planet, not a star, and not like anything we've seen before. This object is eerily round, strangely silent, and detectable only through faint radio waves. It sits far from the galactic hustle, in a quiet pocket of space where few things tend to lurk, let alone something this precise. Its symmetry is almost unnatural, and its presence completely unexpected. Scientists gave it a name that means perfect, but what it is and how it formed is a mystery that's raising eyebrows across the astronomy world. In this episode, we'll unpack the clues, retrace the accidental discovery, and explore why this flawless structure could challenge what we thought we knew about the violent life and death of stars, and the quiet, strange things they sometimes leave behind. It all began with a routine scan of the southern sky. Astrophysicist Miroslav Filipovic and his team at Western Sydney University were poring over fresh radio data from the Australian Square Kilometre Array Pathfinder, a telescope built to map the radio universe in stunning detail. As image after image streamed in, something caught their eye. Nestled in a remote corner of the Milky Way was a faint but unmistakably circular structure. It wasn't labeled, it wasn't expected, and it looked too perfect to ignore. The team had stumbled upon what would later be designated SNRG 305.4-2.2, but they gave it a more fitting name, Teleios, the Greek word for perfect. Its shape wasn't just impressive, it was almost mathematically flawless. When they measured its form, the circularity came out to 95.4%, making it one of the most geometrically symmetric remnants ever observed in space. At first, it was unclear how big it actually was. Depending on how far away it lies, somewhere between 7,000 and 25,000 light-years. Its size could range from 46 to 157 light-years across. But no matter the distance, the shape remains stunningly intact, and it gets stranger. Teleios is only visible in radio wavelengths. Unlike most known structures in space, it doesn't emit an X-ray, infrared, or even visible light, only in faint, low-frequency radio waves. This makes it incredibly easy to miss and even harder to explain. Its position adds to the mystery. It lies 2.2 degrees below the galactic plane, far from the crowded regions where stars and dust normally cluster. That isolation may have allowed whatever force created Teleios to unfold undisturbed for thousands of years, preserving its beautiful, eerie shape in the dark. The team hadn't set out to find this object, but in the data, it practically whispered, "I don't belong here." And that whisper became one of the most intriguing discoveries of recent sky surveys. As the buzz around Teleios grew, so did the questions. What kind of event could create something so precise in a universe that rarely deals in straight lines or perfect circles? In theory, the answer might seem simple. When a star explodes, it sends out a blast wave that should spread evenly, like ripples in a pond. But in practice, most supernova remnants, the glowing clouds left behind after a star dies, are distorted by the messiness of their surroundings. Gas clouds, magnetic fields, nearby stars, and uneven stellar composition. That's why Teleios is exceptional. It appears to be a supernova remnant, but one that formed in rare, near-ideal conditions. Its symmetry suggests the explosion expanded into a smooth, low-density environment, perhaps one of the calmest pockets of the galaxy, and it seems to have done so without interruption. The likely cause? Many astronomers point to a Type Ia supernova, the result of a white dwarf star in a binary system pulling too much material from its partner, reaching a tipping point, and erupting in a thermonuclear blast. These explosions can be highly symmetrical, but they also typically shine brightly in X-rays, which Teleios does not. Another possibility is a Type IX supernova, a weaker version of the type Ia that may leave behind a zombie star, a partially exploded white dwarf that continues to smolder. But if that were the case, Teleios would need to be far closer than current distance estimates suggest. The data doesn't quite add up. Even more puzzling is its radio-only nature. Supernova remnants usually emit across multiple wavelengths, especially if they're young and energetic. Teleios doesn't. It's radio bright but ghost-like in all other bands. This suggests it may be older than it appears, or it may never have reached the high temperatures needed for broader emission. Or perhaps it's something else entirely. What makes Teleios important isn't just its perfection, it's the tension it creates between theory and observation. It challenges our understanding of how supernovae behave, how remnants evolve, and what conditions shape them. If Teleios is a rule breaker, it may be the key to discovering rules we never knew existed. To truly understand Teleios, we'll need more data. Future observations from telescopes like Chandra, XMM Newton, or even James Webb could scan it in different wavelengths, searching for faint emissions that might tell us more about its composition, age, or even whether it hides a compact object like a neutron star or zombie white dwarf. There's also a bold idea gaining traction. Maybe Teleios doesn't fit any of our categories because it represents something new, a kind of explosion we haven't modeled, or a stellar remnant shaped by unknown forces. It's not just an outlier, it might be a clue. Whatever it is, Teleios reminds us that space isn't just filled with noise and chaos. Sometimes it's quiet, sometimes it's precise, and sometimes in that precision, we find the biggest surprises of all. So, whether Teleios is a rare exception or the first of many unseen cousins, it's a sign that space still holds secrets, perfect ones, silent ones, waiting in the dark for someone to notice. And now that we've seen one, we can't help but wonder what else is out there.